This video is about the formation of a corrie. We're going to be looking at the formation of a corrie in 3 stages: before glaciation, during glaciation, and after glaciation. Remember, a corrie is a hollow in the mountainside that's sort of been cut out and eroded away by the glacier. So here we have a slope, and in that slope there's a tiny wee sort of hollow here where snow is able to accumulate. And these places where snow is normally able to accumulate is north and northeast facing slopes. Now that is because, as we know, north and northeast facing slopes receive the least direct sunlight, and also they get lots of quite cold winds, and therefore the snow stays all year round. So the snow is able to accumulate. So snow falls in little hollows like this and sort of builds up over time. So snow falls and collects in these hollows and builds up over time. And as we know, when snow builds up over time and doesn't melt each year, that is when the snow gets compressed, first of all turns into neve, and then turns into glacial ice. So on the top here, we have fresh snow, which then turns into neve, and then we have our glacial ice. So this continues to happen, as I say, and compacts to form ice until eventually our ice is so heavy and it turns into a glacier and it starts to move downhill. So once it's a glacier, it starts to move downhill due to its weight and gravity. And with the hollow here, it starts to move in a rotational way. So it starts to sort of rotate down like this and back on itself. So it's downhill due to gravity in a rotational movement. So we have a glacier and it's now moving under its own weight, as I say, in a wee sort of rotation almost. So now that our glacier has formed, we have ice like so, filling our hollow, and you can see the hollow is already a different shape, much steeper and deeper than it was before, and the ice is still moving in this rotational sort of way, so it's sort of coming down and pushing into the hollow and then coming back round again. So this is where we have our processes, and the during glaciation phase is always very important to talk about processes. So there's 3 processes going on here. First of all, we have freeze thaw. So freeze thaw, now this happens above the glacier, okay, so above where the ice is on the rocks there. And pieces of rock break off because of freeze thaw, and that steepens the back wall. So this is the back wall of the corrie, and if pieces start to break off, that's going to make this back wall steeper. We also have plucking. So plucking happens again down this back wall. And plucking also is able to steepen the landscape. So plucking is steepening that back wall. So pieces of rock are ripped off of this back wall, which again in time is going to make that much, much steeper. Abrasion is also happening at the base of the corrie. So as this ice is moving and scouring down here, we've got little fragments of rock that are sticking out the bottom, and that is going to wear away and deepen the base of our corrie. So abrasion deepens the hollow. And the last sort of thing to mention on here is this bit of the diagram, which is our Berggrund crevasse. So as the glacier moves, bits of it are frozen onto the back wall. So as these bits start to move, you end up with big cracks in the ice that may go all the way down to the base of the glacier, and it's known as a Berggrund crevasse. If you have a big crack like this, it means that meltwater can flow down through this crack to the base of the glacier, and that can increase the erosive power. So the crevasse allows meltwater to the base of the glacier, and that increases the erosive power. So the key things to remember are freeze thaw above the glacier, steepening the back wall. Plucking happening here, again, this back wall is going to, over time, get steeper and abrasion is going to deepen, and then more plucking will happen and more abrasion will happen until that back wall becomes very steep and the hollow becomes our deep corrie. And then after glaciation, this is what you are sort of left with. So we have quite craggy sort of areas at the top of the back wall of the corrie. Freeze thaw still happens, okay, so we still have some freeze thaw above, well, there's no glacier anymore, but we still have freeze thaw on the rocks. And because we still have freeze thaw, where bits of rocks break off this back wall, we end up with a little scree slope in here. So this is a scree slope, which is just a build-up of loose rocks. You'll often see these on corries where material has fallen down from the back wall and collected. The corries often will fill with water to form a corrie loch or a tarn. So after the glaciation, often water will collect here because it is a hollow. And this can be dammed sometimes by a rock lip. So the rock lip here is where maybe the glacier wasn't quite as thick or less powerful, and there's sometimes less erosion. So for some reason, there's been less erosion here. Like I say, maybe the glacier was thinner, maybe the rocks are a bit more resistant, but it's less powerful here. Or we may have some moraine, which is also damming our corrie loch or tarn. So moraine is material deposited by the glacier, and sometimes that can leave a ridge where water can collect behind it. So we're left with our corrie with the steep back wall, the deep hollow, as I say, sometimes filled in by water.